As long as the music's playing, I'm happy. Okay, I want to find f prime. Again, what's the definition? F prime of x equals the limit delta x approaches 0, f of x plus delta x minus f of x divided by delta x. The ugly part to this problem is finding f of x plus delta x. That's the first step, because that's what? X plus delta x to what power? Cube plus 2 times x plus delta x. And now I got to find what that answer to this. I got to multiply it 3 times. I said it's not a pretty one. 3 times. What about for the power of 4 or power of 5? Go ahead.
Isn't there an easier way to do this?
Ah, which way?
You just bring the 3 down, be 3x plus 2.
What is it?
The derivative when that just
Be quiet there.
um,
There's more to that. But be quiet.
Or use that guy's triangle.
I was thinking about that. That's why I thought he's going with it. But he's jumping ahead. He's like in chapter 5, section 5 or 6. I said to him, be quiet. He's in section 5, 6. I can use Pascal triangle, sure, instead of multiplying that out. You know? You know what Pascal triangle is? If you don't want to do this, like multiply it 3 times, start with a 1, 1 and 1. What's 1 plus 1? So start with these 3 ones. What's 1 plus 1? 2, and 1's on the outside. If you've never seen this before, this is actually cool. 1 and 2, 3, 2 and 1, 3, 1's on the outside. 1 and 3, 4, 3 and 3, 6, 3 and 1, 4, 1's on the outside. 1 and 4, 5, 4 and 6, 10, 6 and 4, 10, 4 and 1, 5, 1's on the outside. It keeps going. If you want to find x plus delta x to the 3rd power, this is the 3rd power right there. How do you know which power? The 1st power, the 2nd power, the 3rd power, the 4th power, the 5th power. So these are the numbers that I need. So if you want to find the answer to this one, instead of multiplying 3 times, I like the Pascal triangle. You start with these numbers. I just put them in a box there. Here's the 1. Let's put a space between them. 3, 3, 1. We take the first one, which is x, raise it to the power 3, whatever that power is. Take delta x to what power? 0. So the first one to the highest power, this one to 0. Plus the second term. From now on, each time you decrease this by 1, increase this by 1. X to what power? 2. Delta x to what power? 1. Decrease this by 1, increase that by 1. Plus the next one. X to what power? 1. Delta x to what power? 2. The last one. X to what power? 0. Delta x to what power? 3. You might say, I could have multiplied that a lot faster. Trust me, when the power is 4 and 5 and 6, you don't want to be multiplying. This method becomes awesome. So when you clean this one, that's really 1x cubed. You don't have to put the 1. Plus 3x squared delta x. Plus 3x delta x squared. Plus what? Delta x cubed. That's only the first part. That's the x plus delta x cubed. I still need to add to it what? 2 times that. So let me finish step number 1. So it's going to be x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed, and add to it what? 2x plus 2 delta x. That's why I like h instead of delta x. What's the difference? 1, 2, 3, 4, 5. You lose about 5 letters from this. I don't have to use the parentheses either. That's step number 1. What's step number 2? Step number 2 is what? Find f of x plus delta x minus f of x. And maybe I'll go on the bottom here, trying to put it on the bottom, because I got a lot of junk there. The math teacher watches that, he'll be mad at me for calling the math junk. That's the first part. Subtract from it f of x, which is what? X cubed plus 2x. So we lost the x cubed. We lost the 2x. So the result of step number 2 is what? 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2 delta x. What is step number 3? Take the answer from step number 2 and divide it by what? Delta x. So if we divide each one of these by delta x, what are we going to have? We're going to have 3x squared. Divide this by delta x, it becomes what? 3x 1 delta x. Divide this by delta x, that's delta x what? Squared plus what? 2. Step number 4, last one. Take the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0. What is the limit of the answer from step number 3? That's 3x squared plus 3x delta x plus delta x squared plus the 2. Remember, you're placing delta x with 0, not x. So this piece will go to 0. That piece will go to 0. You're letting delta x be 0. So what's your final answer? That's f prime of x. It's 3x squared plus 2. Because the function was called f of x, that's the limit called f prime of x. The deceiving ones are the short ones. You see a problem that's really short, you go, it can't be that bad. So let me take a couple of short ones. I might use h instead of delta x, just less writing. So don't panic if you see h there in place of delta x. Let's say I was given this problem, y equals the square root of x, and now the question, find dy dx. That's also the derivative. That means what? The limit. I'm going to use h in place of delta x. As h approaches 0, one letter versus 2, f of x plus h minus f of x divided by h. So I'll mix and match. A lot of math books, a lot of them, they use h instead of delta x. Just makes it easier to write. Again, it's 4 steps. Step number 1, f of x plus h. Replace x with x plus h. Can we simplify that? What do you think? Can we break it down to square root of x plus the square root of h? Let me try again. Can you break it down to square root of x plus square root of h? No. Good answer. No, you can't. Not addition, subtraction, only multiplication, division. Step number 2. F of x plus h minus f of x. Can we simplify that? No. Can't. Nothing you can do so far. Step number 3, divided by h. Can we simplify that? No again. I like this problem. Everything is no. Okay, last step. So far, it's smooth sailing. Doesn't get easier than that. Let's take the limit now. And let's find the limit. We know the first step is direct substitution. If you let h be 0, what do you have? 0 over 0, right? Because that'd be a square root of x minus the square root of x, which is 0. Now we got a problem. You know it can't be that easy because it was like moving perfect there.
Can't you multiply the top and bottom by the square root of x plus h plus the square root of x?
Why?
You get rid of the square root on both of them.
What is that called? You're doing right. You're doing good, actually.
No,
That is the right one. What is it? Conjugate. Yep. That's absolutely true. The only way to get rid of square root, multiply by the conjugate. So to get rid of that square root somehow, make it work out. Anytime you have a square root, you're going to be thinking about the conjugate. And the conjugate says you're going to multiply. Notice if you take a fraction, multiply the top and the bottom by 1, it doesn't change it. I'm going to multiply it by x plus h plus the square root of x plus h plus the square root of x. That's called the conjugate. Doesn't change the fraction. You're multiplying the top and the bottom, or you're multiplying this fraction by 1, or the top and the bottom by the same thing. So if you FOIL the top, the bottom, leave it alone the way you see it, h times the quantity x plus h plus the square root of x. But what about the top? What method are we going to use? Begins with the letter F. FOIL method. If you FOIL this, square root by itself, you lose the square root. Next piece. You'll see why we switch the sign. This becomes what? Positive. Leave it like that. Don't kill yourself. It's going to work out nicely. Next one. This one. That'll be minus the square root of x times the square root of what? X plus h. And what's the last one? Minus x. And what do you notice about the two middle pieces? That's why we'll multiply by the conjugate. You got even better. What's x plus h minus x? Yeah, the x's will cancel out. I can cancel the h's, but I'll wait. I'll make it nice and neat on the next page. Now we're going to have the limit as h approaches 0 of h over h times the square root x plus h plus the square root of x. Again, oh, made this too big. And the h's will cancel out again. It's the limit as h approaches 0 Now let h be 0. What are you going to have? One over 2 times the square root of x, and that's your dy dx. Again, that's the slope of the tangent line. You go, a slope is supposed to be a point. Well, that's the equation for it. You tell me where, and I'll tell you what the answer is. Another one might be tricky. Again, color short one's tricky, so that when you see a square root, always think of rationalizing. When you see a fraction, always think of what? Common denominator, LCD. So if I have y equals 2 over t, find y sub prime. I'm trying to use all the notations, at least the common ones. And again, y sub prime means the derivative. It's the limit. I'll use h again for this. That's t here. So it'll be y of t plus h minus y sub t divided by h. If I wrote this better, actually, I should have wrote y of t, because I'm using the variable t. I'm just lazy there. So y of t plus h minus y sub t divided by h. Step number 1, find y sub t plus h. Two over t plus h. Two over t plus h. Can we simplify it? No. Should have a sign that says no on it. Have a question? No. Can't simplify that. Step number 2. Y sub t plus h minus y sub t. 2 over t plus h minus 2 over t. Now, the only thing you can do is find LCD and rewrite the fractions. And probably a smart move to do it now, get it done over with. You're going to need to do it anyway. So I'm going to change the bottom to be what? T times T plus H. So this one here, you need to multiply it by what to make it look like this?
T.
T. So the top should be what?
2T.
2T. To change this to that, we need to multiply it by what?
T plus H.
T plus H. Now, don't try to cancel the T with the T and the T plus H with the T plus H. Now, I've seen people do that. If you do that, guess what happens? You go back right here. It'll be like that gerbil in the cage that keeps spinning, is going nowhere. Your feet are going, but you're not going anywhere. So when you simplify that, what do we have?
2H. T squared plus 3H.
How about minus 2H? Right? Yep, minus, because there's a minus sign here. Good. Step number 3, what are we going to do? Divide by what? H. Well, when you divide that fraction by H, that's the same as multiplying by what? 1 over H. Yep, the reciprocal. H's will cancel. You end up with negative 2 over T times T plus H. Now just the last step, and we're done. Take the limit as H approaches 0. So as you plug in H approaches 0, we're going to have negative 2 over what? T times T, which is negative 2 over T squared. Now there's a couple of places where the derivative does not exist. And I'll point them out. Couple of places the derivative does not exist. We have a function called the greatest integer function. It looks like this. That's the name of it. You see that in calculus a lot. The greatest integer. So f of x, we'll call it f of x equals that function. That's called the greatest integer function. What does it look like? It looks like actually stairs. When x is the 1, the 2, the 3, so from 0 to 1, it has a value of 0 all the way to 1. That's an open circle. When it hits 1, it has a value of 1 here and stays the same till it hits 2. It has an open circle at 2. That means what? The biggest integer between 1 and 2 is actually 1. That's why it's called the greatest integer. The greatest integer between 2 and 3, once you hit 2 and less than 3 is what? That's a 2. And it also applies to negative value, minus 1, minus 2, minus 3. As I said to you, it looks like stairs. It looks like that. That's called the greatest integer function. Now, this function does not have a derivative at 1, at 2, at 3, at 0, at -1, at -2. Why? What's the derivative? The derivative is what? The limit. So what is the limit as x approaches the 2? From the left side is what? 1. From the right side is what? 2. As x approaches the 2. From the left side is 1, from the right side is 2. There is no limit right here, there is no limit 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 there. There is no derivative at -1, at 0, at 1, at 2, at 3. So the derivative does not exist at these integer values. Another one in calculus you want to try to avoid is the absolute value. Absolute value does not have a derivative right at the v. Oh. So for example, let's say I gave you this function. I said f of x equals absolute value of x minus 2. What does the graph looks like? This is the 1, this is the 2. The graph for that will be a v. There is no derivative right here. No derivative. It's the slope of the tangent line. The derivative is the slope of the tangent line. If you look at the tangent line from the left side, it's what? What's the slope of that number from the left side? Negative. From the right side? Can't be. So in calculus, a V shape is always a problem for us. The derivative does not exist there. And the third place where the derivative might not exist, or definitely will not exist, if you have a function that looks like this. Right at this point, what do you think the slope here looks like? Or the tangent line, not the slope. Let's look at the tangent line first. What's the tangent line at that point? This line. And what's the slope of that line? Does not exist. So there are a few places where the derivative does not exist. This is one of them. This is another one. This just only at that point. There is no derivative at that point. There is no derivative at this point. And the greatest integer, there is no derivative right there. And that's the end of section 3.1.